Hello everyone, so today I'll be covering question number 36 of GATE 2007. The influence line diagram ILD shown is for the member. So we are given this influence line diagram and this truss. So it is asked that this influence line diagram belongs to which of the following members. So 4 options are given to us. It's a 2-mark question. The relevant NPTEL reference is given here. Okay, so let's start with the solution of this problem. So let us rule out the wrong options first. Okay, so this truss is given to us. So whenever any load is applied on the truss and at any point, the truss will somewhat deflect like this. I'm drawing the exaggerated version, but it will deflect like this. Therefore, the top chord members are always under compression and the bottom chord members will always be under tension. Okay, so the influence line diagram for the top chord member will always be under compression, while the influence line diagram for the bottom chord member will always be under tension. Since the influence line diagram which is given to us is varying from compression to tension, therefore this cannot be the influence line diagram for any bottom chord member or top chord member. Therefore, out of these 4 options which are given to us, the member RS is a bottom chord member and member PQ is a top chord member. Therefore, these 2 options cannot be the answer. Now, 2 options are remaining, that is, this influence line diagram can be of member PS or it can be of member QS. So, let's start some calculations here. Let's see if it is for member PS or not. We will apply the unit load first at position R and calculate the force in member PS. Next, we will apply the unit load at position S and calculate the force in member PS. Why we are applying the unit load only at position R and S? Because these 2 sections, this section and this section, are the 2 sections which are connected this diagonal member PS, and the influence line diagram will vary in between these 2 sections only. Otherwise, it will remain same. We will see how it is done. Although we need to apply the load only at R and S, let's see what will happen if we apply the load at supports. Right? So let's call this support as A and this as B. Suppose we apply any load, unit load here. Let's say it's unit load 1. Then this support will take all the force and there will be no force in any member. Therefore, in the member PS also the force will be 0 when we apply the unit load at position A. So therefore, influence line diagram will say 0 at this point. Next, similarly, if we apply the unit load at position B, here also the support is there. Therefore, the support will take all the force and there will be 0 force in all the members, and hence there will be 0 force in the member PS also. Okay, so it will be 0 here. Now we can apply the load at the positions R and S. Let's apply the unit load at position R. While applying the unit load, if we apply the unit load at position R, some reaction will develop at positions A and B. So for now, since the span length is not given to us, therefore let's call it R1 and R2. Right. So these are the 2 reactions which will develop. Now we need to calculate the force in member PS. To calculate the force in member PS, let us cut this section like this. So by making a cut like this section is divided into 2 parts, right? So let's call it as section 1 and this is section 2. So it is recommended that we should choose that section which does not contain the unit load. Therefore, we will choose section 2 for our further calculation. Okay, so let's draw this section 2. So this is member PQ. So let's call it FPQ, right? And the cutting of the section will release the forces. So I'm drawing those forces. So let's call it as FPS and let's call it as FRS, right? Other than that, there is a huge truss section here. We do not need to draw that, so I'm drawing it with a dashed line here, right? So it is the complete truss. Just imagine that. Now there is a support here. So the support here, the reaction is R2, right? So we have drawn the second part, second section of this truss. Now what we will do, we will use the equilibrium equation. The equilibrium equation says summation of force in vertical direction to be 0. So what are the forces in vertical direction in this second section which I have drawn? This R2 is in vertical direction, which is upward, so I'll write it as positive R2. And what other force? Let's call it as theta. So FPS sine theta is also in vertical direction and it is upward, so therefore we'll call it as plus FPS sine theta. There is no other force in vertical direction, therefore it is 0. From it we can calculate the value of FPS as minus R2 divided by sine theta. Since by default I have considered the tension as positive, therefore from our calculation we got that force in FPS is in compression, right? So we can draw it somewhat here, right, because below the baseline for compression. Now we will shift this unit load to position S, and similarly like this step we will calculate the force in member PS. So now I'll apply the unit load at position S. So this will also generate some reaction. Let's call it R3 and R4 here. Now again the same step, we will cut the section in this way. This will generate two further sections, this 1 and 2. So as I have told earlier, we will choose that section which do not contain the unit load. So here we will choose section 1. I'll redraw this section 1 again. So it is FPQ, it is FPS, and it is FRS. We'll draw the remaining section of this truss and we will say this is reaction R3. Again we will use the equilibrium equation, that is summation of force in vertical direction to be 0. Let's see what are all the forces in vertical direction here. So there is R3 which is in upward direction, so it is positive. There is also sine component of FPS, but it is in downward direction, so we'll take it as minus FPS sine theta and equal to 0. From here we will calculate the value of FPS as R3 divided by sine theta. So our value is coming out to be positive, that is in tension. Therefore for load location S we can draw it as above the baseline and positive. We do not know the exact value here, but we just know that it is positive. Now we can join all the things. We can join it like this, this and this. We do not need to apply the unit load in all these positions, because even if we do that, it will come here and here only somewhat. So we do not need to do that. If we want, we can do that, but there's no need. It's just a waste of time for us. Therefore, this is the ILD for member PS. Let's see if it is matching with the given ILD or not. Yes, it is matching. It is for the member PS. It is varying from compression to tension as the answer we got. Therefore, at this step only we get our final answer. That is, this is the ILD for member PS. That is option A is correct.